All right, boys and girls, so this is the data that I had you help me with. I asked everybody to please tell me what their age was, and if you were one of those that didn't respond, don't worry, because I went in to my computer and I found your birthday and I figured out how old you were. And so this is every single buddy's age in our class. And today, we're just assuming this is our class. So of course I'm a member of our class, and today Miss Burt gets to be a member of our class instead of Miss Natalie. We're having Mrs. Burt be a member of our class, and then here's all of our classmates. Okay, the only person that wasn't on this picture is Willow because she wasn't here when we took pictures, but we still included Willow. Okay, and so if you were here, boys and girls, I would be asking all of you I would be gathering data on all of you, and I'd be asking you the question, how old are you? Okay, and so we're going to figure out the mean or the average age of people that are in our class. Okay, so I'm going to use this to help me, and then I'm going to write it on the board. Okay, so we have 12, 11, 12, 11, 11, 12, 11, 12, 11, 12, 12, 12, 1, 2, 3, 4, 5, 6, 7 more 12s. 1, 2, 3, 4, 5, 6, 7. 7 more 12s. 12, 1, 2, 3, 4, 5, 6, 7, 11, 12, 12, 11, 12, 11, 12, 12, 12, and then we have Mrs. Glover and Mrs. Burt. So there's all the data for ages of people in our class. Now, as you look at that, if we were going to pick one number to represent how old people in our class is, I want you to look at that data and I want you to think about what it would be. Now, to find the mean, or the fair share, or the balance, we would add all those numbers together, and then we would divide by how many there is. Okay, so there's 37 data values. Okay, so we're going to add them all together, and then we're going to divide by 37. Now, for the sake of time, I did that ahead of time. So altogether, boys and girls, it's 518. That's all of these data values added together, divided by 37. And that's going to tell me what the mean is. Okay, and 518 divided by 37 is 14. Now, is that fair? Is it fair to say that on average, students in Mrs. Glover's, or people in Mrs. Glover's 6th grade class is 14? Okay, I'm going to guess that you're looking at those numbers and you're thinking, nope, that's not fair. Why is it, boys and girls, that makes it seem like you guys are actually older than you are? Because actually nobody in our class is 14, and as much as you'd like to be, you're not even close to 14. So why is it that because of this data set, it makes it seem like you're so much older? Okay, I'm guessing that you've realized that because of me and Mrs. Burt, we are so old, boys and girls, that these two data values make it seem like our class is actually older than they are. Okay? And so sometimes we have a data value that is so much more, or sometimes it's so much less that it affects the data. Okay? And that's called an outlier. And that's what we're going to talk about today. We're going to talk about outliers and the effects that they have on data values. Okay, so if we go over here and we look at our problem, okay, this is lesson 12.7 in our book. It says, the table gives the number of days that the 24 members of the Garfield Middle School volleyball team were absent from school last year. And so as you look at that table, boys and girls, this is how many days students missed. Okay, so it says use a dot plot to find the outliers. Remember, an outlier is a data value that is a lot bigger or a lot smaller than other data values. Okay, so going through, boys and girls, we're going to put a dot on 4, dot on 6, dot on 7, another dot on 4, 2 dots on 5, a dot on 3, a dot on 6, another dot on 6, dot on 7, dot on 3, dot on 5, dot on 8, dot on 16, whoa, a dot on 5, dot on 4, another dot on 5, 6, 5, 7, 6, 4, 5, and 4. Now, looking at that, okay, we have lots of data values here, and one data value there. Okay, this is, boys and girls, what we would consider to be an outlier. It's a data value that is a lot further away than the rest of our data values. We have this big, huge gap right there in our data. And so that's what we would consider an outlier. Now, the thing that's important about knowing outliers is outliers can affect your data. They can make it seem like the mean is more or less than it should be. And that's what happened over here. Because Mrs. Burt and I are so much older than you guys, it made it seem like on average, or the mean of our class was actually higher than it would be ordinarily. Okay? All right, so here's another example, boys and girls, with outliers. Remember, an outlier is something that's a lot more or a lot less. So as I read through this problem, I want you to be thinking to yourself, which of these values might be an outlier? Okay, it says the high temperatures for the week in Foxdale in degrees Fahrenheit were 43, 43, 45, 42, 26, 43, and 45. The mean of the data is 41 degrees Fahrenheit, and the median, or the middle number, is 43 degrees Fahrenheit. Identify the outlier and describe how the mean and the median are affected by it. Okay, so the first thing we're going to do, boys and girls, is we're just quickly going to put this information on a dot plot, and we're going to see what our outlier might be. Okay, so we have 2 43s, actually 3 43s. Okay, 2 45s, a 42, and then a 26. Okay, so looking at that, boys and girls, it's pretty easy to see most of my data is right here, except for this one piece clear down here. That's what we call an outlier. So it says the outlier is 26 degrees Fahrenheit. Now, there's some kind of important information that it gave me in my problem, and I want to just quickly point that out. Okay, it says the mean of the data is 41. Remember, the mean is the fair amount, and it's saying this is the mean. 41. Okay? The median is 43. So right here, boys and girls, this is the median. Remember, the median is the middle number. If we were to take all of our data values and line them up from smallest to biggest, where would the middle be? That's the median. Okay? All right, so now it's saying find the mean and median of the temperature without the outlier. So this time we're going to leave that 26, we're going to leave it out. Okay, so we have 43, and we had 3 of those. 43 plus 43 plus 43, plus we had a 42, we had 2 45s. Okay, and all together now without the outlier, boys and girls, there's 1, 2, 3, 4, 5, 6 pieces of data. So to find the mean, we're going to add each of those together. We're going to divide by 6. All right, so I have my calculator. I'm just going to add those up. So 43 plus 43 plus 43 plus 42 plus 45 plus 45 equals 261 divided by 6 is 43.5. So without the outlier, boys and girls, the mean is actually right here. Okay, so this is without the outlier. Now, this would probably be a more fair estimate of temperature, and it would be probably more fair to say on average the temperature was 43.5. Okay, before we were saying on average the temperature was 41, and that was lower than every single day except for this one with the outlier. If we have a number that's a lot smaller, boys and girls, for an outlier, that means all of these numbers have to share more to get it to balance. Okay? So I want you to think, what if we had a number that was a lot higher? What effect would that have? Okay? If it's a lot higher, if we had a number clear up here, maybe they had a day that was 90. That's going to affect the mean because it's going to make it bigger. Okay? All right, let's look at the median. Let's see how it affects the median. Remember, when we do the median, we put order numbers from least to greatest. So our smallest value without the outlier was 42. And then we had 3 43s. And then we had those 2 45s. We had 6 data values, which means there's 2 right in the middle. So we had 2 43s right in the middle. So boys and girls, this is something you can probably do in your head. But what's the middle of 43 and 43? It's just 43, right? Because 43 plus 43 is 86, and 86 divided by 2 is just 43. Okay? So when we look at the median before was 43, and the median now is still 43. Okay, I want you to think about why that is. If we have an outlier in our data set, it's either going to be the very smallest or the very biggest number. And when we find the median, we just bounce in and find the middle, right? So outliers don't affect the median, okay? But they can really affect the mean. And so it's important to know that when you're looking at a data set, that if you have an outlier and someone is telling you, oh, on average, this is what it is, it's going to be affected by that outlier. But if they're saying the median, that would be a better value to use when you have an outlier. Okay, so today, as you work with outliers, remember, outliers are always our very biggest number or our very smallest number. Okay, and as always, if you need help, reach out to your teacher.